Good morning, dear students. Welcome to this class on prestressed concrete subject. Last session, we have talked about the properties of hardened concrete, where including durability, stiffness of the concrete. Okay, and what shall be the minimum cement content, maximum water cement ratio, type of cement for different chemical exposures like majorly sulfate attack, and finally what is the maximum cement content of no, in a concrete uh, that you can permit. Okay, so against 530 from the earlier code is being changed now to 450 uh, kg per cubic meter of concrete is the maximum cement content that you can uh, permit in the concrete per cubic meter of concrete. Okay, right. Now let us talk about today's content, which is called high performance concrete. So you have to understand the two different things here. So high strength concrete is different from high performance concrete. High strength concrete is purely the strength is high. Okay, so uh, high performance concrete, the performance of the concrete in terms of the following aspects is being prepared. Okay, so this is what is the difference. So high strength concrete, you will have higher strength than the normal concrete. Okay, like M20, right? Whereas high performance concrete is like it will have the following properties, like it will have high strength, and as well it will have shrinkage and creep minimum, and it will have high durability, and it will be very easy to prepare, like easy to cast the concrete cubes, concrete members, and cost effective. Okay, so these are the properties of high performance concrete. It is nowadays popular in concrete where you need high strength concrete. Okay, so the clear difference between high strength concrete and high performance concrete is to avoid the uh, the attributes where you have a problem with the high strength concrete. Okay, so high performance concrete will have the property of high strength, as well as in addition to that minimum shrinkage and creep. Okay, so creep and shrinkages will be minimized, and durability is enhanced, and casting made easy, and cost effective. It is cost effective. Okay, so traditionally high performance concrete implied high strength concrete with higher cement content and low water cement ratio. So in general, what does it mean? In general, if you want high strength concrete, means what? We will increase the cement content and we will reduce the water cement ratio. So you get high strength. But what happens if you increase cement content? It leads to autogenous and plastic shrinkage cracking and thermal cracking. That is a problem. So autogenous cracks, shrinkage cracks will increase. Autogenous shrinkage cracking, what we call. So shrinkage cracking will have two types of shrinkage losses that we will discuss in detail in the further classes. Thermal crack. As you are increasing cement content, the heat produced during the concrete preparation will get increased, and hence thermal cracking is also increased. So at present, durability is also given importance along with the strength. That's why uh, the high performance is nowadays replacing the high strength concrete. Okay, earlier it was high strength concrete was the need, and we have problems with the high strength concrete, like the heat produced will be, heat on hydration is very high, heat of hydration is very high, and the shrinkage cracks will be very high, and durability is less. That's all. These are the problems with the high strength concrete. Hence, to overcome the problems with the high strength concrete, we have devised high performance concrete. Okay, where it will have much higher strength and lesser shrinkage and creep, durability very high, easy to cast, and also cost effective material. Right. This is what does mean high performance concrete. So there are even some special types of high performance concretes are also available. So depending on the need of uh, the project which you are handling, right? So if you want purely high strength concrete, it is high strength concrete. And if you want high workability, you can make it. Self compacting concrete, you can make it. And reactive powder concrete, where the cement is replaced with reactive powder, some portion of partial replacement. High volume fly ash concrete, where again we partially replace cement with the HVFA, high volume fly ash. Fiber reinforced concrete is very popular, where we use fibers. Again, different types of fibers are there: glass fibers, steel fibers, likewise. Okay. So fiber reinforced concrete is also comes under high performance concrete. This depends on the specific need. So to improve the flexural resistance, we go for fiber reinforced concrete wherever there is a need for fiber. I mean, increase of tensile strength of concrete. Okay. So likewise, you have different types of even some special types of high performance concretes also available. So where the first one includes very traditional high strength concrete and high workability, and wherever you have compacting is a problem, we go for self compacting concrete. And reactive powder concrete, high volume fly ash concrete, fiber reinforced concrete. Okay. Right, in a post-tensioned member, the concrete next to the anchorage blocks, that means otherwise known as end block, subjected to high stress concentrations. As I told you, the ends of the pre-stressed concrete member ends of pre-stressed concrete member are highly stressed, where the load transfer is going on. Okay. So the type of concrete at end blocks shall be different from the rest of the member. Okay. So they are specially made. End blocks are to be specially casted. So where fiber reinforced concrete is used to check the cracking due to the bursting forces. So those are tensile forces, bursting forces called. Right, hook tension we come across something like that. So that will be to improve the tensile strength, as I was telling, fiber reinforced concrete is the best suited one for the end block preparation. Okay, so this is about high performance concrete, which we'll be using nowadays, right? Now, coming to permissible stresses in concrete, after introducing what is meant by high strength concrete, what does meant by high performance concrete, all different properties that it has, like compressive strength property, tensile strength property, like durability and all, likewise stiffness. Now we will see, uh, to exactly analyze and design a pre-stressed concrete member, how much stress you can permit into the concrete. Okay, so these are mentioned in clause 24.3 of IS code. Okay, the allowable stresses, which are very much essential for an engineer to analyze and design the pre-stressed concrete members. Okay, so all these allowable stresses are given in IS code. You don't need to worry about all these diagrams to remembering, likewise, right? So they are readily available in IS 1343-2012. Okay, so have a copy of it with you for your ready reference. Okay, so you can open your IS code. I told you strictly to have a copy of IS code. Have a copy of IS 1343, physical copy, hard copy. Take a hard copy of IS 1343-2012. Refer whenever you listen to this pre-stressed concrete uh, lesson. Okay. Right now, you can open this 24.3 class 24.3 of IS code and see that you find these diagrams. What are they? How we will be using them? I'll be telling you now. Okay. So you can see what is this diagram given below. They are allowable compressive stresses under flexure. Okay. So flexure means bending. So bending causes both compressive and tensile stresses. So let us talk about how much compressive stress due to flexure will be allowed in pre-stressed concrete member. Okay, right. So there are two things that you have to see when you talk about allowable stresses. One is, I mean, we have talked about stages of loading. One is a transfer, intermediate, and at service. There are three things. If you refer back to my lectures, there are three stages of loading. Okay, where stresses are induced in the members. One is at transfer, means when you induce pre-stress into the member. Okay, transfer stage means what? You pull the tendon, and when you prepare the concrete, like both either pre-tension or post-tensioning, once you release the wire, that is going to come back, tries to come back to its original position, where the concrete surrounding it will not allow, and that uh, the stress whatever you induced in the tendon will be transferred to the concrete. That is what is called transfer stage. So at this transfer, how much stress you can permit in the concrete? That is what is these diagrams. Okay. So the cube strength at transfer is denoted as FCI instead of FCK. That you have to see clear difference between FC K and FCI. Okay, as FCK characteristic compressive strength at 28 days, whereas a transfer can happen maybe in pre-tension. You can even transfer at 7 days. Okay, it's your no design aspect. Okay, post tensioning maybe if you can have whatever number of days the transfer takes place, that you have to take as it as FCI. Okay, the cube strength at transfer is denoted as FCI. Okay, so for a case of pre-tensioning for a grade of M40, minimum grade is M40. Post tension minimum grade is M30. Till M60 grade, so for a particular case I take, so pre-tensioning, in case of pre-tensioning at transfer, okay, how much for a grade of M40 concrete, how much stress is permitted? Compressive stress under flexure is permitted. 0.51 times of initial cube strength or cube strength at transfer. Okay, right? So maybe the number of days at transfer that you make. Okay, right? So this is what does it mean? 51% of the strength of concrete is only permitted. Okay, up to 51% of, say if FCI is, just for example, 100 megapascal. So the stress, that compressive stress in bending that can develop is only 51 megapascal, not beyond 51. Okay, you have to design the member such a way that the compressive stress in bending should not be more than 51 megapascal if FCI is 100. Okay. Similarly, for a grade of M60, it is 44%, and we have been talked about till M80. So you can even extend this line to have M80 by extrapolating this line. Okay, you can even go for M80 also. Okay, so M80 grade. So that is what the codal provisions made. And for post tensioning, a little bit higher values of stress are permitted uh, for lesser grade of concrete. And for M60, it is 0.37 times of FCI. Okay, for post tensioning members. Got it? So for a pre-tension member, these are the allowable compressive stresses in bending. So remember, we will use FCI instead of FCK for allowable stresses at transfer. Okay, right. Next, going for the allowable stresses in concrete at service loads, means when the member is loaded with the service loads like live load, dead load, and all. Okay, that is in the preparation stage. At transfer means the pre-stressing is going on. Okay, once the pre-stressing has done, immediately after pre-stressing, that is what is called transfer. Okay, and whereas at service means the pre-stressed member is now in use, that it is taking the service loads. Okay, where at transfer means what, the member is taking the pre-stress. Okay, whereas at service means it is taking the loads, live load and dead load. Okay, and these are the stresses where after the member is prepared, now you have the member which is in use. Say for if it is a beam, it is in use, it is taking the dead loads and live loads. For a grade of M30, the value that is now is 0.41. Now it is FCK, because when you are permitting loads means it is already beyond the 28 days period, so always we can go for FCK utilization. So already strength of the concrete has crossed 28 days. Okay, so FCK can be very well used. Okay, right. Then what is this zone 1 and zone 2 means what? So zone 1 represents the locations where compressive stresses are not likely to increase. Means no change in the stresses. Once it is loaded, no change in the stress. That is, in such cases, you use zone 1. What is zone 2? Where the compressive stresses are likely to change, means increase. Okay, so such cases where, for example, vehicle movements on bridge decks. Okay, so those are called transient loads, which means uh, sometimes it is loaded, sometimes not loaded. So when vehicle moves, load is applied. When vehicle goes off, load is not there. Likewise, okay. So such loads are called transient loads. So from vehicles on bridge decks, in such cases we go for zone 2. If it is a building, normal building structure, we use zone 1 curve, zone 1 values. If it is a bridge deck, we use zone 2 values. Okay. So you can see that the transient loads that if a bridge deck is having, we permit lesser compressive stresses to develop at service loads. Okay, so we have more safety. More safety is taken care of uh, at service loads. Okay, right. So we use these values for now at service loads for what flexural compressive stresses. Okay, these things what we are talking about, allowable compressive stresses under flexure, and this is given in section 24.3 of IS code. So take your code, open class 24.3 and see whether you can find these diagrams or not. Okay, right. So allowable compressive stresses under direct compression, where it was flexural compression, which we have been talked about. Uh, Now we will talk about allowable compressive stresses under direct compression. Okay, so where direct compression is mostly by the pre-stress only. Okay, or else direct compression, a column member which is under direct compression. So for direct compression, except in the parts immediately behind the anchorage, the maximum stress is equal to 0.8 times the maximum compressive stress under flexure. Okay, so whatever the values that we are using under flexure, so maximum stress that is permitted is equal to 0.8 times those values. Okay, so for direct compression, except in the parts of end blocks, the remaining portions. Okay, so direct compressive stresses are again taken as 80% of those values, flexural values. Means what? The 80% of this value, 80% of this value. Likewise, okay, except in the end block, right? Right. Now coming to the, so we have talked about flexural compressive stress, direct compressive stress, now the tensile stress under bending. Okay. So the pre-stressed members are classified into three different types based on the allowable tensile stresses. So the three types are being mentioned here. The amount of pre-stressing varies in the three types. The allowable tensile stresses for these things are again mentioned in the class 24.2 of your IS code. I'll just show you that code also uh, for your reference. The purpose of providing hypothetical values is to use the elastic analysis method for type 3 members even after cracking of concrete. So, briefly, now type 1 member means uncracked member. No tensile stresses are permitted. So, tensile stress is 0. Okay. So, allowable tensile stress is 0 for type 1 members. Okay. So wherever it is necessary, for example, liquid retaining structures. So you shall not have any tensile stress at all. So you cannot permit any crack. Okay. So we use type 1 as we call that members as type 1 member. Okay. So where no tensile stresses are permitted. And where type 2, even if the some tensile stress is developed, if it is okay for you in a particular structure, then you limit that to 3 Newton per mm square. Okay, so limit the tensile stress in bending to 3 Newton per mm square. And for temporary loads, if you have any, uh, you can increase that value to 4 point. So this is called type 2 member, where type 1 tensile stresses will not be permitted at all, it is 0. And type 2, we will permit some value of tensile stress. Okay, and whereas type 3, it is called cracked member. Okay, so cracks are permitted, and the allowable tensile stresses are also given even after cracking. We assume that it is going to be behave like elastic member, and we carry on with the analysis. Okay, that is what is the purpose of giving those the hypothetical values, which are not to the exact point, right? So even after cracking of concrete, that's why, so we take this as cracked member. Okay, so let us see that code, yes, code once, just for your reference. I'll just show you the whatever mentioned clauses in the lecture. Okay, so even you also can have a look if you have the IS code with you. Okay, so 24.2, clause number 24.2. Okay, this is all 23 what you see. So 24 is the class 24 of IS code is limit state of serviceability. So where 24.2 we shall go. So limit state of serviceability cracking, and you can see that type 1 member no tensile stress. Type 2 member, the tensile stresses shall not exceed 3 Newton per mm square. Right. So however, likewise, so you have these 24.2 clause, and you can see that 24.3.2.1 is given the diagram that you have just seen, and here it is. Okay, at transfer and at service final due to final pre-stress. Okay, so this is that's what I told you, that if you have IS code with you for ready reference, You don't need to worry about remembering all those diagrams and all. Okay, right. So uh, this is about the permissible stresses in concrete that we have talked today's lecture. And in the next session, we'll talk about the other properties of high strength concrete like shrinkage and creep. Okay. And also the deformation characteristics which are mentioned in your syllabus, right? Thank you.